All right, guys, please go ahead and copy these down into your notes. We are going to start here. That being said, if you guys did not watch the video that was posted for yesterday, you're going to be a little bit lost. There was a video yesterday that was posted on our daily page.
Wait, on the e-learn? For e-learn?
Yes. Yep. Because we're doing examples with the half-angle formulas, but that video goes over where these half-angle formulas came from. So far, in Chapter 7, we've got our sum and difference formulas for sine, cosine, and tangent. We have our double angle formulas for sine, cosine, and tangent. And now we have half-angle formulas for sine, cosine, and tangent. In the video for yesterday, in addition to where these formulas come from, there are 2 examples using it. You're welcome. I had a really good question earlier today, which is, on the test, are you going to tell us whether we have to use a half-angle formula or a double-angle formula, or if I want you to use a specific formula, I would have to tell you that. Otherwise, it would be what things do you have available to you to be able to actually find and calculate this. Because I'm thinking of things like sine of 15 degrees. I could do that with a half angle, because 15 is half of 30. Or I could do that with a difference formula, 45 minus 30. I can get to 15 degrees. So I can get there different ways. For 22.5 degrees, though, I can't think of anything on my unit circle that has 0.5s. So I'm going to have to use a half-angle formula for this one. There's going to be 2 pieces of information that I need to do any of these half-angle problems. One, I need to know what quadrant that half angle is in. (22.5 degrees). What quadrant is that going to be in? First quadrant. That matters because if you look at these half-angle formulas here, it's plus or minus a radical, plus or minus a radical, plus or minus a radical. Well, if I'm in the first quadrant, is it plus or is it minus? It's going to be plus, because everybody's positive in the first quadrant. So I don't want any final answers that have both a plus and a minus in it. It's going to be one or the other. You have to decide whether it's the plus or whether it's the minus. So far, so good? Okay. My half-angle formulas. To find my half-angle over here, I need to know what the full angle would be. So that's the other piece that I need here. If my half angle, so I'm going to call that V over 2, is equal to 22.5 degrees, then what's the full angle? 45 degrees. Because this is how I get my exact values. 45 degrees is on my unit circle, right? So I need to know that so that I can get some exact values. We're trying to find tangent of 22.5 degrees. I have 3 different variations for tangent of a half angle. The video goes over where all 3 variations come from. It should not matter which one of these you choose to work with. You should get the same final result. So if I pick one and you pick a different one, we should still get the same fully simplified answer. Which one do you guys want to use for this problem?
The first one.
First one? Okay. So I'm going to do, that first one says tangent of V over 2 equals 1 minus cosine of V over sine of v. So tangent of 22.5 degrees, because that's my half angle, is equal to 1 minus cosine of what? Cosine of 45 over sine of 45. Are we good so far with where I've gotten these numbers from? And we're okay with the fact that it doesn't matter that we decided as a group to go with the top one. You might choose the bottom one. We should still get the same final result. Okay. So now I need to simplify it. 1 minus, what is cosine of 45 degrees? Root 2 over 2. And sine of 45? Square root of 2 over 2 again. I'm going to get a compound fraction. Up in my numerator, 1 minus root 2 over 2. So that's going to simplify to give me 2 minus root 2 all over 2, right? And down in the denominator, I have root 2 over 2. Can I cancel anything out to simplify this? I can multiply by the reciprocal. So I would have 2 minus root 2 over 2 times the reciprocal, which would be 2 over root 2. I see that my 2's are going to cancel here. You guys okay if I make this just a little bit smaller so that it scoots up the screen? Yes, ma'am.
The first one in blue, how'd you go from 1 to 2?
Good question. So right here, that's 2 over 2 minus root 2 over 2. I got my common denominator, and then I could subtract them. And so that's how we got to here. We doing okay so far? Yes, no, maybe so. Pedro, are you with me? All right, so I have 2 minus radical 2 over radical 2. Thank you, ma'am. There we go. You're welcome to pick a seat anywhere. Resources are underneath the screen up here. Can I leave it like that? Why not? Can't have a radical in my denominator, so I need to rationalize my denominator. I'm going to need to swing all of this up and around, because I have now officially run out of room. What am I going to get if I distribute a radical 2 to my numerator? What's it going to look like if I distribute a radical 2 in my numerator? Yep, 2 radical 2 minus 2 all over 2. Can I simplify that anymore?
Yeah.
What can I do?
Divide by 2.
Yep. Remember, you have to distribute with division the same way you would distribute with multiplication. So I can factor a 2 out in my numerator. So that'd be radical 2 minus 1 all over 2. And then I can cancel it out. Or you could divide it out of each term. That would be an okay way to do it too. Either way, you end up with the tangent of 22.5 degrees being equal to what?
Root 2 minus 1.
Yep, root 2 minus 1. Beautiful. Do we have any questions before we look at another example using our half angles? Okay. For number 4, I'm after another tangent half angle, right? So I've got 3 options to choose from. While it technically doesn't matter which one I choose, there's one of these 3 that requires less work out of me. So if I'm feeling lazy, which today I am, which of these 3 is going to require less work out of me for this problem? Third one, why?
Because you already have cosine.
They gave me cosine right here. So I'm going to go with the third option because that one only uses cosine. And so I don't have to do Pythagorean theorem. I don't have to draw a triangle. I can just take what they gave me and plug it in. So I've got tangent of theta over 2 is equal to plus or minus an enormous square root sign, 1 minus cosine of theta over 1 plus cosine of theta. You guys remember when I told you in your final answers I don't want plus and minus? You got to pick one, and you're showing me which one you pick based on what quadrant you're in. I know what quadrant theta is in. What quad is theta in?
The
Second quadrant. Because we got 0, pi over 2, pi. So theta is over here in quad 2. Does that mean that theta over 2 is also in the second quadrant? How are we going to determine what quadrant it's in?
Wouldn't it be in the first?
Would it be in the first quadrant? Good question.
At the end, to get theta over 2.
So here's what I'm looking at so that I know for sure each time. If theta is in between pi over 2 and pi, if I cut everything in half, I cut theta in half, I would cut my boundaries in half as well. What's theta over 2 over 2? Theta over 4. Or sorry, pi over 4. No, that was a me thing. You just repeated my incorrect. So this would be pi over 4. I have theta over 2 here. And then this is just going to be pi over 2, right? So if I'm in between pi over 4 and pi over 2, what quad am I in? First quadrant. So if my half angle is in quad 1, do I want the plus or the minus for my tangent? Plus. So I don't have to pay attention to the negative part at all. I'm missing somebody else. I'll figure out who it is later. All right. So now that I know it's the positive square root, I can substitute in what I know for cosine, and then we can simplify it from there. So I need my enormous square root. 1 minus negative 11 over 61. 1 plus negative 11 over 61. We are working with some disgusting fractions for a moment. So up in my numerator, I'm going to have 61 over 61. And then is this going to be a plus or a minus here? Plus 11 over 61. Down in my denominator, 61 over 61 minus 11 over 61. You guys okay if we just do away with those denominators since they're all over 61? I've got that common denominator. I would just rather not write another complex fraction. What is 61 plus 11? 72. Over 61 minus 11? 50. Those are both under the radical, right? So I have radical 72 over radical 50. Can I simplify radical 72? What does it simplify to? 6 square root of 2, because this is 36 times 2. So I have 6 radical 2 in my numerator. What about the denominator? 5 radical 2. Can I simplify that fraction at all? I can make it 6 over 5, because this is 6 times radical 2 and 5 times radical 2, so I can cancel those radical 2's out. I don't even have to worry about rationalizing the denominator, because I can cancel it out and get rid of it. Yes, ma'am.
So when you have the square root of 72 on 50, can you change it to 36 over 25? Or do you have to? You know what I mean? Like, can you simplify it? You can divide both.
Oh, yeah. We could have changed that to 36 over 25.
Okay.
Absolutely. So we could have simplified, like we could have reduced our fraction first and then simplify the radicals, or we can simplify the radicals and then reduce the fraction. Either way, you should come out the same. Yes. All right, so tangent of theta over 2 is equal to what? 6 over 5. What questions do we have? What questions do we have? Yes, sir.
Okay, so why only the first quadrant?
Why are we in the first quadrant? Good question. Very good question. If my original angle theta is in the second quadrant, even if it's all the way over here, let's pretend that this is theta. If it was exactly halfway around at 180 degrees, and I take it and cut it in half, where would that put it at? What's half of 180? 90. Well, if I'm not all the way at 180, let's pretend for just a minute, because I don't know what theta is here. I know what the cosine of theta is, but I don't know what theta is. So let's pretend that theta is 179 degrees. What's half of 179? 80 something. Less than 90, right? Well, what quad are you going to be in if you're less than 90? First quadrant. So no matter how big your angle gets in the second quadrant, if you're in the second quadrant and you cut it in half, it automatically forces your half angle into the first quadrant because it's half of it. Does that make more sense? Okay. Good questions, good questions. What other questions do you guys have about either of these before we do 2 more examples that are very similar? Yes, ma'am. Did I use the last formula because it had a radical? I actually don't normally like the last one because it has the radical. I chose the last one because I was feeling lazy. And both of these two right here have sine in them. I had cosine. I could use them, but I'm going to need to do Pythagorean theorem off to the side so that I can find sine of theta. And then I could use either one of those, yeah. You can use any 3 for the tangents. You use whichever one you are the most comfortable with, or whichever one requires the least amount of work out of you. But these are absolutely interchangeable. So if there's one that you prefer over the others, cool. Stick with it. They'll all give the same output every single time. So far, so good? All right, let's look at 2 more examples like this, and then we'll move on to something related but a little bit different. What do I want on number 5? I heard somebody start to say it. I want sine. I want sine of my half angle. So I'm looking at my sine formula. There's only one formula for sine. Sine of x over 2 is equal to plus or minus the radical 1 minus cosine of x over 2. My angle x is in quad 1, right? So what quad is my half angle in? Quad 1, how do you know?
Because it's in quad 1, then the half angle's in quad 1.
Yeah. If I have an angle that's between 0 and 90, even if I assume that it's as big as it could be, it's at 90, and I cut that in half, that puts me at 45, which is still in quad 1. Make sense? When in doubt, draw a picture or try some test values. If you pick out different angles that are in the quadrant that they're describing for your variable, you're like, let's try something big, let's try something small, where do I end up at? Should put you in the same quadrant each time. I need to know what quad I'm in because what does that affect on my formula? Sine. Do I want positive or negative? Positive. Get rid of the negative part then. We don't need it. So sine of x over 2 is equal to the positive square root of 1 minus what? Two over 3 all over 2, because that's part of my formula. So I have 3 over 3 minus 2 over 3 all over 2, right? So how does my numerator simplify then? 1 over 3. So I have 1/3 all over 2. 1 over 6. Can I leave it like that? Can I have radical 1/6? Why not? Yep, I don't want a radical in my denominator. So this becomes radical 1 over radical 6. I'm going to rationalize my denominator. So how does this simplify then? Square root of 6 over 6. How are we doing? Full disclosure, tattling on myself. I hate the half angle ones. I do them because we need to know how to do them, and they are important for finding exact values, especially when addition or subtraction can't get me there. But the half angles are messy. You doing okay? Let's do one more like this. One more. If cosecant is negative 5/3 and theta is in what quadrant?
First.
Close. Fourth quadrant. Why is this one in the fourth quadrant?
Because negative 90.
Negative 90. So this is quad 4. Where's my half angle going to be then? Also going to be in quad 4. For the same reason that if I'm talking about positive angles, if it's in quad 1, my half angle would be in quad 1. If I go the other way around, negative 90, cut that in half, I'm at negative 45. That's still quad 4. So theta over 2 is going to be in between negative 45 and 0, which is quad 4. And I want to find what?
Cosine.
I want to find cosine. I only have one formula for cosine. Cosine of theta over 2 is equal to plus or minus the square root of 1 plus cosine theta over 2. Do I have a value for cosine theta? Not yet. I like that answer. Do I want positive or negative on this? Positive. Why?
Because
Cosine in quadrant 4 is positive. How do I find cosine of theta?
You can do it 3 square plus 12 the determinant.
Cosecant is r over what?
X.
R over x. R over y. Because it's the reciprocal of what? Reciprocal of sine. If it was r over x, all I would need to do is flip it over and I would have my cosine. All right. So x squared plus y squared equals r squared. So x squared plus 3 squared. Ooh, that'd be negative 3 squared, wouldn't it? Because r can never be negative. It's equal to 5 squared. X squared plus 9 equals 25. So x squared is 16, which means x is what? 4. Plus or minus 4, but because we are in the 4th quadrant, we want positive 4. So what is cosine then?
4 over 5.
4 over 5. So now I have a value that I can substitute in. Big ol' square root, 1 plus 4 over 5 over 2. What's 1 plus 4/5? Yep. 9 over 5, all over 2. What's half of 9/5? 9/10. Can I leave it like that? Absolutely not, please. Can I simplify the numerator or the denominator? Yep, 3 over radical 10. And then I need to rationalize that denominator. So I'm going to multiply top and bottom by radical 10. So cosine of theta over 2 is what? Yep, 3 radical 10 over 10. Let's do something related but different. You guys okay with that? Like I mentioned, there are 2 other examples of using these half-angle formulas on the video. While people are finishing up writing this down in their notes, we're finishing 7-4 today. There will be no other new information that you need in order to be able to complete the 7-4 homework. And I do not have a video or anything extra for you guys to do tomorrow. Juniors will be in the building taking the SAT. If you're not a junior, you'll be at home. As far as for this class, that just means work on your 7-4 homework. Friday, when you guys come into class, I'm not going to have anything brand new for you. We're going to spend that time getting ready for your 7-3, 7-4 quiz, which is on Monday. So because we've been kind of disjointed, especially in 7-4, we're going to spend a review day together. I'll give you guys a review. You can work on it in partners or on your own. Ask me for help. Big thing is going to be coming up with ways to remember the plethora of different formulas that we have. All right. I want to find the solutions for this that are on the interval from 0 to 2 pi. Includes 0, exclusive of 2 pi. This has a half angle in it. So I'm going to do a substitution to get rid of that half angle. What substitution can I make? What substitution can I make so that I can get rid of sine of x over 2? What is equivalent to sine of x over 2? Absolutely. I'm going to sub this in right here. I have plus or minus the radical of 1 minus cosine x over 2. I'm going to bring everything else down. I'm going to have a hard time solving this with a radical in it. What operation gets rid of radicals? I'm sorry, what'd you say? Squaring things. If I square both sides, I'm allowed to do it, but right now, if I square the left-hand side, there's a whole lot going on over there. If I could get rid of this cosine of x and the 1 by moving it to the other side, plus or minus the square root of 1 minus cosine x all over 2. Now that is equal to negative cosine of x plus 1. Now, if I square the left-hand side, is there a whole bunch going on? Nope. If you do it to one side, though, have to do it to the other side. So I do have to square this, but over on the right-hand side, I'm just squaring a binomial. If I square a positive number, what kind of result do I get? If I square a negative, what kind of a result do I get? Still positive. So squaring this side not only gets rid of my radical, but it means I don't have to deal with that plus minus anymore. So I'm going to have 1 minus cosine x over 2 is equal to what? Cosine squared x. We are going to have a plus 1. Don't forget your middle term. When we square a binomial, you square the first one, yes. You square the last one, yes. Multiply your two terms together and double it. Yep. Minus 2 cosine x. Because if I were to write out negative cosine x plus 1 times another negative cosine x plus 1 and double distribute, I'm going to end up with negative cos x minus cos x. So far, so good? How do I get rid of the fraction? Multiply. By what? By 2. If you do it to one side, got to do it to the other side. All right, so I have 1 minus cosine x equals 2 cosine squared x minus 4 cosine x plus 2. What do you notice about this? It's quadratic. And quadratics we always want equal to 0. So I'm going to subtract 1 from both sides. And I'm going to add a cosine x to both sides. So it's going to cancel and cancel. So I have 0 equals 2 cosine squared x minus 3 cosine x plus 1. So I'm going to need to factor this. Two things that multiply to give me a positive 2, but add to give me a negative 3. Negative 2 and negative 1. I like to use factoring by grouping. If you like doing an area model, a box, that is fine with me. So I'm going to have 0 equals 2 cosine squared x minus cosine x minus 2 cosine x plus 1. I'm going to make my groups. What can I take out of my first group?
Two cosine.
I can't take out the 2,
Oh.
or at least not with the way I made my groups. I can take out a cosine, and that's going to leave me 2 cosine minus 1, right? I forgot my x. Oops. What can I take out of the second group? Negative 1. And that's going to leave me with cosine x minus 1. Oh, come on. Sorry, I'll get that out of the formula here. Come on. There we go. So that means my factors are cosine x minus 1 and 2 cosine x minus 1. What do I do with each factor? Set them equal to 0. Guys, I see a lot of heads down and a lot of people on phones. This is really important that you're following along. It's very hard to recreate if you haven't had the practice. I realize this is about as exciting as watching paint dry. We'll make it through today, I promise. 2 cosine x minus 1 equals 0. So that means cosine of x is equal to 1/2. Where is cosine x equal to 1?
5/3.
And that's where sine of x is equal to 1.
No. Yeah, 0.
At 0. Where is cosine of x equal to 1/2? Pi over 3. And 5 pi over 3. So those would be my solutions. There's one last thing I want to touch on. It's actually pretty fast. We're going to do some verify problems, but I promise you, these are really fast. I know. I can probably do it in 3, honestly. Normally, I like to start on the most complicated side, but I'd like to start here. Because what do you notice about the relationship between 10x and 5x? 10x is what? It's twice as big, right? It's 5x times 2. So I could rewrite this as sine of 2 times 5x, right? Don't I have double angle formulas? Look over here. Sine of 2 times an angle. Well, if I let this be u, how could I rewrite that using my double angle formula? Sine of 2u is equal to what? 2 sine u. What are we having u equal? 5x. Cosine u. But u is 5x. What was I trying to get this equal to? Yep. 2 sine 5x cosine 5x. Left-hand side equals right-hand side. Six theta, what's my relationship here? Guys, I got like 90 seconds. I'm using them all. 6 theta, its relationship to 3 theta. Twice as big, right? So this is cosine of 2 times 3 theta. 3 theta is my angle u. What's my double angle formula for cosine? Cosine squared of whatever u is. In this case, that's 3 theta. Minus sine squared of my angle, which is 3 theta. And that's exactly what I had on the other side. Told you I could do it. Beautiful. 7-4 homework is due Friday night. You guys have tomorrow to work on it. Friday we'll review together in class, so if you wanted to work on it some then too, you're welcome to do that. I will give you a review for the quiz that you will have time in class to work on. I will not lecture at all on Friday. I am a resource. You guys can work together or ask me for help, but there will be no lecture on Friday. We will start class on Monday with your 7-3, 7-4 quiz, making sure you know the half angles, the double angles, and the sum and difference is going to be key to doing well on the quiz. After the quiz on Monday, we will start the last section of Chapter 7. Have a good one, everybody. I will see you on Friday for most people.